Okay, so welcome back to part 2 of the linear systems exam review questions. And so what I'm going to do is just wrap up question 2b, and so that's the solving of the linear system by graphing by hand. And then I'm going to move on to the calculator portion of the review question. So once again, as I did in the previous example, what I want to do is graph each of these linear functions. In order to do that, I want to identify first the y-intercept, and so I have a y-intercept of positive 2, and the second thing I want to do is identify the slope, which is the coefficient of the x when the equation's in the form y equals mx plus b. So in this case I have a slope of 1 over 1, which is a rise of 1 and a run of 1. And then what I'm going to do is join those two in order to construct my line, and I'll just extend the line the other way, make sure it's nice and long. Okay, that's the first line, and then I'm going to repeat the process with the second line. You can see that in the case of the second function I need to do a small rearrange first. I must get it in the form y equals, and so I'm going to add 3x to both sides, and I have y equals 3x plus 5, and that was achieved by moving the minus 3x from the left to the right. Once again, I need to identify my y-intercept, which in this case is going to be plus 5, and then my slope, which is going to be 3, or 3 over 1. And so I'm going to go 1, 2, 3 up, 1 to the right. So 1, 2, 3 up, 1 to the right, because it's a rise of 3 and a run of 1. And then once again I'll join those. And so let me select a different color, hopefully. And we'll go right through over there as carefully as we can. And what remains to be done, of course, is to identify the coordinates of the point of intersection between those two lines, which in this case are at x equals minus 2, y equals 0. That's the point of intersection, the x value and the y value. So that is the solution to the linear system. And then the other thing we really should do is to provide a couple of labels. And so I'm going to label the y-intercepts of the points, or rather the y-intercepts of the lines that I graphed. Okay. Alright, so what I'm going to do is move now on to a very similar looking question, the difference being this time I'm going to solve the linear system graphically, but using the TI. And so what you're going to do is go to your home page, you'll select graph in this case, or alternatively you can go into your document menu, and you can create yourself a new document. So the alternative is to go onto the home page and create a new document, and what I'm going to do in this new document is add a graph. So immediately at the bottom I have f1 of x. I'm going to come back to the question over here quickly. A little bit of work to be done here. As before, as you can see, it's in function form, so what I'm going to need to do first and foremost is rearrange both of these equations. And so I have 3x minus 1 is the first equation. Move the 1 to the left hand side. In this equation I'm going to move y to the right and the 9 to the left, and so that should leave me with positive y because it moves to the right, and 2x minus 9. So that's my linear system. Those are my functions. I'll now come back to the calculator and sketch a graph of each of those. So I'm going to type in f1x equals, and what I need to type in is 3x minus 1, and I'm going to hit enter. That's my first function. And then in order to be able to type another function in, if you just push tab, I will type the second equation in, which is 2x minus 9, hit enter. And what you can see from this straight away is that the graphs, the two lines, are heading towards each other, but they're going to intersect somewhere down here, way off the graph. And so we want to be able to modify our window, and so we can do that by selecting the window so if we go into menu, we will have the option to modify the window, and one option is to zoom out. The other option, of course, is to go to window settings and manually change the window. So I'm just going to use zoom out in this case, and I'll just do that one more time. I'm going to go back into the menu, and what I want to do is analyze the graph, and from the analyze menu I want the intersection. You're asked for a lower bound. I go to a point on the left of the point of intersection, hit enter, move to the right of the point of intersection, and here we have our coordinates of our point of intersection, -8, -25, and then the last little piece would be to ensure that that is represented on the graph over here. So I'm just going to sketch a couple of lines over there which approximately represent what I'm seeing on my calculator. So there's my first line. I'll change colors and select a second one. Go back into the line menu and we'll change colors. The second one is going to have a y-intercept of -9, and so we're going to have a graph that's going to look a little bit like that, approximate representation. And then what I'm interested in doing is writing down the coordinates of the point of intersection, which in this case -8, -25, and that is how we're going to solve a linear system using the TI. So one more are the same. In this case, we don't have to rearrange either of the equations. What I'll do is I'll go back into my document here and I'll add a page, control document. That's going to add a page. I'm going to add a graph. And once again, I'll just type in the equations. And so it's 4/5 x minus 2. So 4 divide 5x, 4/5 x subtract 2. That's going to give me my first equation. The second equation, hit tab, and we're going to type in x minus 5. Hit enter. Once again, our intersection point is going to be off the right of the graph here. And so what I'll do this time is I will modify the window using the window settings this time. What I can see is I probably need to increase the x maximum because the point of intersection is off to the right. So I'm just going to make that 25. In this case, I've clearly got enough for the x, but I'm going to need to go back in and modify the y value. And so I'm going to increase the y maximum to, let's say, 20 just to be safe. And here we can clearly see our point of intersection. Go to the menu, go to the Analyze Graph function or option and find the intersection. Once again, select a lower bound, a point to the left, a point to the right, and we have our intersection point of 1510. And so let's go back and draw a very quick sketch of that. We have our first function, our second function, if it'll let me draw a second function. There we go. And we'll go back and mark our point of intersection, our solution to the system, as 1510. Okay, and what we're going to do now is move on to the last page, hopefully. Yes, the last page of questions. These are word problems, and once we've set the word problems up, we have the choice, of course, of using any method. So these questions appear on the calculator paper because you can use a graphing method to solve them. Okay, so word problems, we have a rectangle which has a perimeter of 60 and the length is 8 more than the width, you are asked to find both the length and the width. So those are going to be our two unknowns. Instead of x and y, we're going to be solving for L and W, the length and the width. First information we have is that it's a rectangle with a perimeter of 60 centimeters. And so hopefully you realize that the formula for perimeter is twice length plus twice width. And that's going to give us 60. This is where our first equation comes from. The second equation comes from this relationship that the length is 8 more than its width. And so the length is 8 more than the width, so it's the value of the width plus 8. Okay, and so what we have in this case is the ability to solve this either by graphing or to solve this by the elimination method. And so what I'm going to do is a little bit of rearranging first of all, and so I'm going to write this as length minus width equals 8. And so all I've done is I've moved width to the left hand side, and I'm solving by the elimination method. I'm going to multiply the entire equation by 2. Twice length minus twice width is equal to 16. And then the last thing I'm going to do is combine these two equations in order to eliminate, as you can see from here, it will eliminate the two w's or the widths. And so if I add those two equations, I'm going to get 4 multiplied by the length is equal to 60 plus 16 is going to give me 56 divided through by 4. And I'm going to get a length of 14 centimeters in this case. And then if you want to know what the width length is, then I'm just going to substitute back into either equation. The easiest one I would suggest is this one over here. And so we have 14 equals width plus 8. Move the 8 to the left hand side. So it becomes 14 subtract 8. And we have a width of 6 centimeters and a length of 14. Okay, and very quickly I'm just going to wrap up the last one as well. Same kind of approach. Once again, a word problem. What we're looking to do is set up a system of equations that shows the cost of renting each type of room. And so the two kinds of rooms that they rent at this hotel are single occupancy and double occupancy. Okay, so again, we have two unknowns, and so we need to set up two equations in order to be able to solve it. And so key information, a double occupancy room is $20 more than a single occupancy. And so what that means is we can say double occupancy is equal to single occupancy rate plus 20. And so the double occupancy is 20 more than the single. And then our second equation will come from this other given information. A total of $3,115 was taken in after renting 15 double occupancy rooms and 26 single occupancy. And so 3,115 is the money that they took in. That money will come from 15 multiplied by the cost of a double occupancy room plus 26 multiplied by the cost of a single occupancy room. And again, we have options here whether we want to solve this by graphing or whether we want to solve this by algebra or elimination. So what I'm going to do in this case is I'll solve it using the calculator. I'm effectively going to treat D as if it's the Y variable and S as if it's the X variable from the point of view of the calculator. So I'm going to do a quick rearrange over here, and so I need to get D by itself. So I have 15D is going to equal 3,115 less 26S, and then I need to divide through by 15 in order to get D equals 3,115 less 26S all over 15. And those are my two equations. I'm now going to go ahead and enter those on my calculator. And so let me just move that over. Okay, and so what I'm going to do is once again add a page, and I'm going to add graphs, and my function this time is going to be y equals s plus 20. So in this case I'm going to use x plus 20. You cannot use s over here, your calculator does not treat it as a variable. So there's my first function, and you see nothing appears on there. Of course, hopefully by this stage you realize that is because we need to modify the window. Okay, what I'm going to do is push tab. Oopsie, I'm going to push tab. It's going to allow me to enter my second equation, and I'm going to use parentheses this time because I have 3115 minus 26. Remember, I'm treating the s variable as x, and that is going to be divided by 15, and I'm putting both of them in parentheses because they're both being divided by 15. Once again, I hit enter, I don't see anything, and so now I'm going to go in and modify my window by zooming out in this case. And now we begin to see our graph. Our point of intersection is what we need to find next. So we're going to analyze the graph, find the intersection point, point on the left. Oh, sorry, let me just redo that. Analyze the graph, intersection, go to the left for the lower bound, go to the right for the upper bound, and our point of intersection 68.7, 88.7. So we have 68.7, 88.7. 68.7 is the X value, and in this case the X value is our single occupancy room. 88.7 is our double occupancy room, and so that answers the question of how much it costs for a single occupancy and how much for a double occupancy. And then the last little piece just asks how much the hotel would make if it rented 11 double occupancy and 29 single occupancy. And so that's an application. All we need to do for this is a quick substitution. And so we have 11 multiplied by the double occupancy rate plus 29 multiplied by the single occupancy rate, and we can just do that calculation on the calculate menu of our home screen. And so we have 11 multiplied by 88.7 plus 29 multiplied by 68.7, and 2968 is the total amount that the hotel would make. Okay, and that is the end of part 2 and the end of the Unit 1 review questions.